Hey folks, Mr. Bucko here with your target for 11.1 in advanced algebra, where your target is to be able to identify a polynomial and its components. And then we'll do some other things with polynomial too. But this is 11.1 for those of you keeping score at home. So some vocabulary associated with this, which is why I kind of have the word components in the target, is these are all the things that we want to understand and know and be able to identify and apply and note of here as we're working with polynomials. The first thing we have to be aware of is what the degree of a polynomial is, and we'll talk about that here in context in a forthcoming video, if not this one. So you want to know the degree of a polynomial. You want to know the term of a polynomial or a term of a polynomial. You'll be able to identify that and say what one is. You'll also want to know what a polynomial in x of degree n is. I'll define that here in just a minute. And then you'll want to know standard form of a polynomial. What is the standard form of a polynomial? What are the coefficients of a polynomial? What is the leading coefficient of a polynomial? What is a constant term or just a constant? Those two things mean exactly the same thing. A constant term or just constant, something we have seen before. And then a polynomial function. So a lot of spooky language here. Looks a lot scarier than it actually is. These things are actually quite easy to identify, but there's just a lot of vocabulary that goes along with polynomials in general. So the definition, the formal definition according to your textbook of a polynomial in x of degree n, and that sounds scarier than it is this. I'll just read this and then explain kind of what this is. A polynomial in x of degree n is an expression of the form a sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 power plus a sub n minus 2 times x to the n minus 2 power plus so on and so on and so forth until we get down to where the exponent on the variable, in this case x, because it's in x, is 1, and then we have a constant term. And n is a non-negative integer. So what that means here is that if we're working with a polynomial, the exponents on the variables have to be integers, and they can't be negative. They're going to be positive numbers. So this number here, n, is going to be a positive integer. And then as a result, all the rest of these exponents will be integers as well, because we're subtracting 1, 2, so on and so forth until we get down to an exponent of 1 on the variable. So n has to be a non-negative integer, and then a sub n can't be 0. So in other words, this first term has to be a number that's not 0, because if this number is 0, then this will go away, and then we don't have a polynomial at all because there's nothing there. So this number can't be 0. Again, that sounds maybe a lot scarier than it actually is once we see this in context. This complicated looking thing is not as complicated as it might seem at first. So first example here, let's go for one example, is we have a polynomial. This is a polynomial here, and we can simplify it, and we're going to list all the coefficients once we do so. We're going to tack a couple of the vocabulary words associated with polynomials here through these efforts of kind of listing these coefficients and simplifying this. So when I look at this, whether I know it's a polynomial or not, it is, but whether I know it's not, I see some like terms. I have an x squared and then a plus 3x squared. So what I can do is I can simplify this. So that's what I'm going to do first. I'm just going to simplify this because I know I can do that. So that simplifies the 4x squared minus 16x to the 4th plus 96. This is a polynomial. We have non-negative integer exponents, and then we have some coefficients that go along with it, which we're going to list in just a moment. So what I'm going to do is I'm going to take this expression that is a polynomial, because we have variables and those variables have exponents, and it's a polynomial in x. And when we say it's in x, it just means that x is the variable. We can have polynomials in any variables or in more than one variable as long as the exponents are not integers. And we have some coefficients that go along with those. But this is a polynomial in x, because x is the variable. So I'm going to kind of reorganize this a little bit. And I'm going to call this negative 16x to the 4th plus 4x squared plus 96 is exactly the same as this. What I did was I reordered the polynomial from the largest exponent down to the next largest exponent down to this term right here, it doesn't have a variable at all. This 96 is the constant term. It's the constant term because there's no variable being multiplied by this number. So it's just that constant term. So here's our polynomial right here. And then if I want to list the coefficients, if we go back to the definition of our of a polynomial, the coefficients of a polynomial are the numbers a sub n minus 1, a sub n minus 2, all the way down to a sub 0, and the polynomial a sub n times x to the n, so on and so forth. So the coefficients are, so what we've heard before, they're all the numbers that are in front of or being multiplied by the variable. So technically you could say that if I have this expression or this polynomial, technically we would say that negative 16, 0, 4, 0, and 96 are the coefficients according to this definition. I would say that, or be fine with, the coefficients are negative 16, 4, and then you could say 96 according to this definition of coefficients. I wouldn't say you'd have to throw in the zeros, but you can, but there's nothing there anyway. So these would be the coefficients. The coefficients are just the numbers that are being multiplied by the variables. So those are the coefficients of this polynomial. So we'll want to simplify that first and then list the coefficients according to what the definition of a coefficient of a polynomial is, according to the text with which we're working. So what are the degree and the leading coefficient of this? So we have this expression. We've simplified it to this right here, and I can't make those circles go away, so we'll kind of pretend they're not there. So let's maybe look at this one. This one's better, I would say, anyway, because the zeros aren't there. So what are the degree and the leading coefficient of this? The degree is the largest exponent in the polynomial. So if I look at this expression, the largest exponent is 4. So therefore, the degree of this polynomial, or this one, because it's the same thing, it's just simplified, the degree is 4. And then the leading coefficient is directly tied to the degree because the leading coefficient is the coefficient of the term with that largest exponent. So the leading coefficient here would be 16. Why is it 16? Because negative 16. Because negative 16 is being multiplied, or is the coefficient of x to the 4th, which is the largest exponent. So the degree in this case is 4, and the leading coefficient is negative 16. And the last question is, we can rewrite the polynomial in standard form. Well, I already kind of did that up here, and standard form is when you just have the largest exponent down to the next largest, down to the next largest, all the way down to a sub 0, which is the constant term with no variable at all. So maybe a better way to write this in standard form, or another way to write this in standard form, or maybe a more clear way to do it to make more sense is what I did right here. I have 4, 3, 2, 1, and then no exponent at all. So this might be a better way to look at or think about what standard form of a polynomial is in x. And again, we're just working with one variable here. Once we throw in other variables, things start to get a little bit more confusing or different. But if we're just working with one variable, which is all we're doing here, this is that standard form where you just have the largest exponent down to the next, until you get to the exponent 0.